Dear participants, let us move for the next session. And the topic of next session is intellectual property rights and commercialization in additive manufacturing. And the expert for this session is Minister Neeraj Kumar Mahi. I think Minister Neeraj has joined us already. Hello, sir.
Yes, sir. Very good evening, sir.
Thank you, sir. Thank you.
Very good evening.
Mr. Neeraj Kumar Mahe has more than 15 years of industry experience in the field of CAD/CAM. He completed his diploma, BTech and MTech in mechanical engineering. After his graduation, he completed his post-diploma in CAD/CAM and certification program in CAD/CAM. Currently, he is serving as a senior design engineer and leading research and development department of GNA Gears Limited. He is an authorized engineer for basic design and advanced design in Creo from PTC University, USA. He is certified from Autodesk USA for professional user of Autodesk product. He is certified from Sandvik India Limited for digital manufacturing process. He is authorized and certified engineer for robotics programming. He is certified on PLM from Parametric Technology Corporation, USA. He received his advanced training of CAD/CAM, CAE, FDM, IoT, and AI from different countries and has visited China, UAE, Malaysia, Singapore, etc. He has done 1100 plus industrial CAD and CAM projects for plastic, forging, and sand casting and pressure die casting industries. He has done 250 plus projects, 3D printing projects for different industry. He is also providing consultancy to different industry for new product development. He was invited by IIT, NIT, and all other institutes for having works on current and latest technology used by mechanical engineers. He is also providing engineering services, solutions, and consultancy to more than 100 industries. So I would like to thank Mr. Neeraj for joining us, and over to you, sir.
Thank you very much, sir. Thank you. Thank you for your support, and thanks again for inviting me for this wonderful session and to share my experience with you all. So without wasting much of time, sir, so I would like to start. And sir, now my topic is, so is this visible, sir?
Yes, sir, it's visible. Please share your PPT. Minister Neeraj, please show your PPT, sir. Thank you, sir.
Is this visible, sir?
Yes, sir, it's visible. Thank you.
Right, sir. Right. Thank you very much, sir. And I'll really thankful to the entire management of Amritsar Group of Colleges for this inviting me for this wonderful session and in this 6-day faculty training program. So my topic for this lecture is emerging trend in additive manufacturing of advanced materials for industrial application. And let me clear you about something about my group where I am working, and I am holding more than 16 plus years of total experience. So after my graduation, I have done many certification courses in the same technology, and I joined GNA in 2006. So from the same day I'm working there, and in my group, so it is very old group. You can say that the third Prime Minister of India personally visited to our group in we established in the year of 1946. So talk about our growth. So we are aimed with the 78 of total years of growth as of now. So our turnover is near about 3200 crores. So we have quality management system, environmental management system. So these kind of certifications we are already holding. So we have four industries. GNA Gears, where I am working, is the GNA Gears, GNA Excel Limited, GNA Excel Limited 2. These are totally, we can say that the spare part manufacturing industry. So we are the OEM manufacturer, and along with that, we are having own GNA Aviation Wing. So in my industry, so we spread near about 5,75,000 square meter of technological resources. We have integration of design and manufacturing on own our own R&D. So I would like to say you that we will make this session interactive. So it is not like the ordinary FDP is like मैं बोल रहा हूँ और there is no response from other side. So you may put any question anytime. So it will be very grateful if we can work on like this same platform. Try to communicate in this entire lecture. So I will be very grateful for you. So we have a manufacturing capability of 90 different kind of products. So we have near about 3,200 crores turnover. We in my industry we are working with a 400 plus CNC, HMC, and VMC. We have a dry cutting. So we have 4 CMM coordinate measuring machine. This is entirely we have used this machine for the reverse engineering and quality control purposes. So we have biggest hammer. Capacity of the hammer is all about 800 ton. We are working on the robotic forging. We have 3D printer, CNC hopper, CNC broaching, and all other machines are there in my industry. So we are the spare part manufacturer, and these are the some of our product range. So we manufacture crown, tail, and pinions. So we manufacture epicyclic assemblies. We manufacture bull gears. We manufacture bull pinion shafts. We manufacture speed gears. So we manufacture flanges, hollow flanges with spindles, axle. So when we start in 1946, when we have started, so uh, that time our production was 2 axle in a month, and as of now we are exporting more than 2 million axle per month to different of the companies. Like I'll show you. These are the some companies: Caterpillar, Class India, Ashoka Leyland, Dana India Limited. Like some of famous companies are Escort International, Sonalika International Tractor Limited, JCB, John Deere, Kubota, Maruti Suzuki. So it is a major customer. Kubota, it's a tractor company. So Mahindra and Mahindra, along with the same Swaraj, Tefe, Tata. So to them we are used to supply number of components, uh, number of components every month. So the along with that we are having like this 320 plus multinational companies. They are being associated with us. So I just make a very simple presentation just to clear about the basic fundamental of the 3D printing, and where is the origin of 3D printing, what factor affecting onto this 3D printing process. So let me clearly brief you about the process planning. So I just want to check, is this visible? Presentation is visible? Hello?
Yes, sir. Yes, sir.
Yes, sir. Is this visible, sir?
Yes, sir. I think your screen is not visible. Yes, sir. Yeah, it's visible.
Okay, sir. Okay. Thank you. Thank
Continue,
you
sir.
very much.
Continue.
Okay, sir. So this is a process planning for any product to be developed, and in the R&D cell, as of now, they are having some particular division. It is called NPD. So generally, it is called New Product Development Division. So in the entire industry, so they are working with the requirement analysis first of all. So they just they are having a team. It can be of digital media, it can be of physical media. So they just analyze the requirement of customer. So once they will be having requirement of customer, they will put all those parameter and they will make a new design. And what comes to the design next, comes to the design is a prototyping. So this is the mandatory, and it is a today's topic because this is the hot topic of today's century, prototyping. So before prototyping, design is there. And if we are not having design with us, so we can not be able to do prototyping. So we will be having the next step, we will be having customer evaluation. So after evaluated from the customer, we we can give, if the customer gives approval for the same component, so we can put the component for the development, and there are a lot many machines are there for the development, testing of the component, and release in the market. If any changes are there, then it will again comes to the requirement analysis. Then this is the process, like it will goes along with any of the company. And let me clear you about the process of design first of all. So I request you all, अब मेरे सीनियर भी हैं सारे, so हम इसको इंटरेक्टिव बना के वी विल मेक इट इन ए वेरी इंटरेक्टिव. सो आई विल पुट यू द क्वेश्चन in between this entire presentation. Is this okay, sir?
Yes, it's clearly visible, sir.
Yes, sir. Yes, sir. Sir, can I ask the question in front of this presentation, in between the presentation?
Yes, please, you can, sir.
Yes, sir. Thank you very much, sir. Thank you. And sir, prototyping is a very small topic, but what is base on this prototyping is design. So along with the design, it is again talk about the materials, processes. It is again very broad area, but its base is almost about the design. And in the industry, we are having three kind of designs are there. So very first kind of design is concept design. So these are the three major category of design. So concept design, but prototyping is this stage. So when you go to this duplicacy reverse engineering, then we are having at the last we have to do the prototype. But before that, we are having three stages: concept design, component design, and duplicacy. So what include in the concept design? So it is something related to the freehand working. It is something related to the freehand sketching. Means without any dimension, we can just make a new concept, and it is on the paper. Then later on, we can draw it in the software. So other one is the component design. In the component design, so we will having 2D drawings, and by reading those 2D drawing, we will convert the model to the 3D. And other one is the duplicacy, and it is a very popular in India because we people used to duplicate the entities. We just copy and paste from the other companies. And this chapter include reverse engineering. This is called RE. So number of jobs are available in RE for the mechanical engineers. Even in the freelancing jobs are also available for the mechanical engineers. If they are having good experience or good knowledge in design, they can be able to work with any of the company as a on the freelancing website. So reverse engineering is further of the three type: image tracing, 3D scanner, and mirroring instruments. So then after we will get a CAD model, then we can go to the 3D and 4D printing, and along with that 3D scanners are there. So I will clearly explain this to you, and I have make some sort of models for the demonstration. So I will give you the demonstration of all this. So in my industry, we are the user of Creo software and NX software. I just open this Creo software. So I just show you how that basically concept design is working. So what's based on this concept design? So so we have more than 300 plus teams are there working with us in the different softwares. And this is the product of PTC company, is a parametric technology corporation. So I just set it, and I'll start it as a concept. Is this visible, sir? My screen is visible.
Yes, sir. Visible, sir.
Okay, sir. Okay, thank you, sir. Thank you. So let's start with the new concept. So something about from the home appliance company, let's say. So how the engineers are working. So I'll put the image in this concept only. So suppose I'll clear along with this chart. Requirement analysis is, yeah, we have to design one bowl for any of the company, or one water glass, or one cell phone, or anything, whatever we need to do. So the requirement comes from like home appliance company, so they need to design one bowl. So it comes to the requirement analysis. They will put all to the design department. As I told you, there is one division called NPD. It's a new product development division. So they will put all the requirement to the design department, and in the NPD there are the concept designer and the CAD designer, CAD modeler, clay modelers are there. They will put everything under this concept, and they start working on this. Let's say they have to design a bowl. So first of all, they will make a bowl with by taking rough dimension. They said this is 70. Let's say dimension of this bowl is 70, and they will make it 35. So even after this, they have just make a hollow from the inside. This is the concept number one. Very looking very odd, but this is a concept number one to design a one bowl. So I just put this in the PPT for the reference, and this is the my concept number one. And the what they will do, because I have design, so they will take my design to the prototyping, customer evaluation. They have make a prototype, they send to the customer, review, the customer is not good, then they will redesign. Customer they have simply said that okay, no, shape is not good. So then the new product development team, they will again start working. They've just make a fillet out of it. They just make it modified it like this, and they just create a new model again. So again, I just make a bottom cutout, because from the bottom it is having a spherical shape. So I just make it cut out, and like this cutout, and I just may remove a material. So this is the concept number two. So I said I want to have this much material removal, and I will make a fillet out of it. So again, it's a 5 mm radius. So I have this concept. By having this only, so what include in the prototype, it is very easy process to have a prototype. I just control P, and I will select the printer, and it will make select that printer, whatever printer we are having in an industry. So we have three printers: CC series, Phase 300X, Design Jet series are available in my industry. So I just give OK, and when I start OK, it will start printing onto the that machine. But in between that, there are some file conversion is there. So I'll clear you later on this lecture only. So it is my concept number two, and this is, suppose this is the concept number two, and again I'll put in this. It is far better than the first one, but the customer is again not satisfied, because once it'll go reach to this evaluation, they have just review it, and they'll again ask to the design department that these kind of bowls are already available in the market. What's new in your design? What is new in your, then they again start, okay, right, we have to change it. So they will add another shape. So they just inquire with the number of industry. They have just make a cutout over here. So they just include this cutout. Even we are working also. So we have just copied and paste from the other companies what they have done, what we have to do. Like this we are following. So like this, I'll just make a pattern over here, and I'll make 7 cutouts to be there having the same category. So out of this, I just modify it. So I'll make a fillet over here, and I just pattern it out, and these kind of fillet I wanted. This is the concept number three. So in this concept, it is the some special bowl, but it is the bowl having a far good shape from the first two models, but it is this model is liked by the more than 80% of the customers. But again, evaluation, there are some sort of changes. They want actually new product. So here the concept design will work. So freehandly we are added some different kind of shapes to this model. I just make a rough cutout and I just make a, let's say, this, and I'll make it, twist it. So okay, and even also this is a new model, and even also I will assign different colors to this model. I'll just put up a color and I'll make this ball to be having a glass color, and I just make an application in this. It will give me the rendered model. So this is the actual model. So maybe, sir, you have clearly understand that if out of these four, even also we can have a good option of color change, so we can change the color quickly. So this is the power of design. So I just make a ball of this kind of, and I just make a snap over here. So once I'll click a snap of this model, so I just paste the snap in this PPT again. So this is the concept number 4, and we all knows that this is the something extraordinary. And if we presented to someone like we are going to design a bowl of this kind of color and this kind of shape, so everyone likes this bowl. So this is the first parameter of design, and this is the concept design. Now, once my design is ready, so I'll again go to make us this prototype, and it is, if it is customers are satisfied, so we can have a number of different materials for this prototyping. Some sort of, you can say that more than 150 plus materials are available for prototyping, so under subcategories. So we can just select the printer, say okay, and that printer will build the same model whatever we have designed over here. So this is the first criteria. Even also, so even also, uh, I'll clear you about something about the concept design. I think I have explained very briefly about this concept design. I hope you understand the process of concept design. So next category is the component design. This is the toughest one, as we are the OEM, we are the original equipment manufacturing company. So we are working with the component design. In the component design, we will get the dimensions, and we need to work with the dimension all the times. We cannot go out of dimension. Like this is the one example. So if someone wants to design this kind of model, so he or she need to play with the dimension. So we cannot go beyond from the dimension, as we are using to develop in during as we are developing during in my industry. Like we have this component, and it is the crown. We make this for the JCB. So this is the forging drawing, and we included everything in the dimension. So we cannot change the dimension. We cannot go beyond from the dimension, as we have get from the company. So tight tolerances are there. Maybe you have heard about the GT&T, geometrical dimensioning and tolerancing. So we need to take care of all the geometrical dimensioning and tolerancing. By taking care of geometrical dimensioning and tolerancing, we need to design this model. And once it is designed, so now I'm going to explain you something about this uh, component design. So 2D to 3D conversion. We will get 2D drawings, so we need to convert those to the 3D model. So as we get this to the 2D, and by taking all the dimension in a proper aspect, so we will make this model. Like this is the first one. So they have mentioned like the model is having draft angle. So I know maybe you clearly understand the function of draft angle. In the practical application, we need to make it taper from the side, so that it can be easily ejected from the die once it is undergone for the forging process. So this, another coupling I have had, this is just for the flange. You can say that the flash area, we need to mention the flash area whether we are working with the uh, forging component. So in the forging component, we need to take care of the round fillets. So we need to have fillets in all the corners. If we are not having fillets, so the forging product will not come out in a very good manner. So we need to fillet it out, and all the cutouts. This is another cutout, and another draft we need to add, another round we have to add. So this is the final model, and we have ready this model as per the expectation of the company or as per the drawing given by the company. So let's say I'll close this model for some sort of time. So I'll just open and I just make another kind of third kind of CAD. Somewhere we can get a CAD model. It is a duplicacy. It is a reverse engineering, and in the reverse engineering, very first topic is the image tracing. So in the image tracing, we will get a concept design like this. I'll come to the PPT again for some period of time. So like this, they are making a concept. This is one, two, three, and at the end, final model. This is the final rendered model, and this is all in the CAD softwares. So we have make it, and once the model get ready, then we can convert the model for the 3D printing. So this is again a concept design, and this is again a new concept design. So I'll give you one example. Suppose they have ready this concept first of all. If this is not good, they have ready this concept first of all. Then finally, if the concept comes okay, then they will ready a CAD model. So like this, they will make out of the concept, they will make a CAD model, finally rendered model. Like this is the rendered model, and I'll show you this example also. So I prepare because by taking care of time, uh, I just make another model so we can check it like this model. This is a model, and we have just make, and these are the cutouts available. So we can be increase or decrease cutout as per the need. So I just want to have a number of cutout like 35 cutouts to be there. So this is, I will make a 35 number of cutouts. So height increases. So it's increased with the height of that one. And if we want to decrease those cutouts, so we can decrease the cutouts. Like I want to have a 20 number of cutouts, so it will increase and decrease. This is how we can work with the concept design. And this is the first kind of concept design, and I'll already explain you about the bowl. So this is the second model of the concept design. And other, even also, if we want to increase this angle, so I just open this and I just make it to the number of angle increment like 7 degree instead of 5 degree. I want to increment the angle of one to other plate with the 7 degree. So it rotates as per the 7 degree. This is 47, 45. It will become 52. It will become 59 degree angle. So it is all with the help of these 3D software. This is the concept number two. So like this, we will create a model, and I just put into the rendered studio. So I just create a scene and I'll just put it to the any of the scene available in the software. So we can just put up there only. So we will not be able to clearly understand whether it is a clear captured image or the software image. We can click the picture from the here. We can directly for the digital marketing. So the customer will order from the website, and once we will get a good order, receiving good number of order, then we can be go further for the manufacturing of this model. So this is all in the concept design. So another one is the component to 2D. Like I'll already clear you about that. It's some dimensions are given, and we need to work with the dimension. And we cannot go beyond from the dimension. This is the second kind of duplicacy models. So other one is the measuring instruments. So sorry, reverse engineering. Other one is the image tracing, and I'll clear you about the images. Sorry, I forget to share. So this is the image tracing method of reverse engineering. So we will get a concept design, and by taking those concept, by the having number of good software, Alias software is there for making a concept design onto that software. Even Katia software is there. In the Katia, in the Alias, we can directly convert all those models from the sketch to the real world image. And by having these kind of concept, so I'll clear you with the help of this video. In this video, so it is clearly brief you about that 3D printing. So one is okay, let we will having image and we need to trace it out. So by having like image tracing in the, even some students are also following this in the drawing sheets tracing. So by having bulb behind that drawing sheet, they will easily tracing that drawing sheets. So that is all. That is the some sort of image tracing. We will having concept design, and in the software we just put up concept image in the software, and by taking care of all the edges, all the surfaces, we just make a splines onto those edges, and out of that we can able to clearly make a one surface like this is happening. So by joining all these little edges, we can able to make a surface over here. This is the image tracing method of CAD. Another one is a 3D scanner. Nowadays, it is very popular in start from the home appliances to the medical industry and to the transport design. 3D scanning is the hot topic nowadays. So in the 3D scanning, what is happening? So I'll share you one video. So in this video, we can have idea how the 3D scanner is working. So along with the video, I'll just clear you out. So in this video, so they are just scanning. So they are just scanning foot and for making some artificial leg. So as I told you before, we cannot go further if we are not having that 3D model. So they have just scanner. This is a white light scanners are there. So for scanning purposes, white light scanner, blue light scanners are there. So they have just scan a real model, and they will make a CAD model out of it. Another, this is left and right both side. So scan foot, scan right foot, scan left foot. So we are getting this CAD model, and we can just simply transfer this. This is in the medical sciences for the organ transplanter. So we can transplant the organs with the help of this, because 3D printing is nothing. We just want to have idea where the input comes for the 3D printer. So these all are the inputs, and these are the methods of the 3D print to have some good input for this 3D printing machine. And other one video is, in this video I'll share you about that further. Sorry. Okay, this is another video. So in this video, so it is clearly gives you an idea about. So these all videos are available on YouTube. So this is how the 3D printer is working. So it is talk about the hardware. So I would like to say you that this is the blue light scanner. So we place a component in the table, and blue light falls on onto that model, and it will give us the point cloud data. So even this is a second method. This is a portable scanner. So generally the dummies at the outside of the clothing showrooms, so they have just make man stand over in front of the scanner. They just put those all those parameters and all those cameras. They will click a snap, and it will convert those all snap. They will club together, and it will convert that those snaps to the 3D model. Another thing is this laser scanners. There are three type of scanners are available: blue light scanner, white light scanner, and laser scanner. So along with that, portable scanners are there. So in the portable scanner, even some scanners are there. We can easily capture the color of the model. So whatever.
ऐसी ਗੱਲ नहीं हैगी।
ਇਹ ਸੁਣੀ ਹੈ ਨਾ ਨਹੀਂ ਠੀਕ ਆ ਇਹ ਵੈਸੇ ਹੀ ਇੰਨੀ ਕੀ ਸਹੀ ਹੋਣੀ ਹੈ
Dear participants, kindly mute yourself.
ਇਹ ਨਹੀਂ ਸਹੀ ਫੋਟੋ
ਨਹੀਂ
Dear participants, please mute yourself.
Sorry. Thank you, sir. Thank you. So I'll again start with this video. So white light scanners and blue light scanners are there. So out of all those scanner, we just scan the model. And this is very interesting part is to make a dummy out of it. Like they have just scan it and parallel to that computer. So in any CAD software, they'll just give you the CAD model. Like once they will scan, so I'll show you. So we already I worked for one project for someone company is there. They have just scanned the human being to make a dummy for this clothing showroom. So onto that we will have a subtractive manufacturing. We have done a subtractive manufacturing. So we just create this in the NX software. So we are also using NX software for this 3D printing and for the programming. So I just open once the blue light or white light scanner. So they will act and immediately they will give you this kind of model. It is a scanned human for placing in front of the clothing showroom. So we will get this kind of model after having scanning. So later on we can be do this further programming by using AI robotics. So we are the ABB. We are using ABB and KUKA robots in my industry. So this is how we will scan it out. So that scanner will give us this kind of input in the form of CAD model. So once we are getting CAD model, we can directly shift the CAD model to the 3D printer. So 3D printer will give, even the commercial printers are there. The bed size is 10 feet by 12 feet is also available. So onto that we can able to print the entire human within the 2 or 3 days of working time. So once it is a very quick process. We just scan the model. This is the duplicacy. As I'll come again to this slide. So in the reverse engineering, because as I told you, we are based on duplicacy. If some company launches a new phone, let's say iPhone. So they have Apple launches iPhone, and immediately other companies, what they will do, they will just 3D scan that model. They will, after 3D scan, they will get a model, and by taking that model, they will customize the design. Whatever camera they want to dislocate, whatever where they want to dislocate the flash, where they want to increase or decrease the width of that component. So they will be done with the help of 3D scanned model. And other one is the uh, I hope it's clear uh, how this 3D scanning is working. So I'll again give you one idea about this video. So till the meantime, I would like to take one break for 1-2 minute for your questions. I am here only. So break for your questions. Anything you want to ask as of now we have discussed. Anything, please, you are free to ask. Yes. Any questions? Please ask. It will really encourage me to elaborate more clearly.
Neeraj sir, carry on.
Right, sir. Right, sir.
Okay. In the end, we
Okay,
will ask the questions. You carry on, sir.
Right, sir. Right.
It's
Thank
a
you.
wonderful
Thank you.
presentation.
Thank you. Thank you, sir. Thank you very much, sir. Thank you.
Okay.
So I hope I clear you about this concept design. It's a freehand sketching. Other one is a concept component design. Onto this, we need to take care of the dimension. Other one is a duplicacy. We just duplicate the component of any of the company. It can be automobile company. It can be home appliance industry, it can be medical industries, medical sciences. So they just duplicate. And nowadays 3D scanner play a very good role to duplicate the things. Let's say if in some of the accident, let's say if someone met with the accident and he just lost his left foot. So what the doctor will do, they will just scan the right foot and they will mirror it out. It will become a left foot. They just print out with the help of bioprinting, and they just fix with the patient, and immediately that or that whatever organ they've just replaced, they will start functioning. That kind of possibility is there in the duplicacy kind of CAD model. It is the 3D scanning purposes, and 3D scanner, after 3D scanner, and this is the typical method used by the all companies of this local region. So they are, because all this is the experience in the image tracing. It needs expertise. If we are not expert for tracing image, so we cannot be able to get CAD model in a very good manner. So other one, 3D scanner, this is a costly process. In India, we can say that 10 to 13, 10 to 20 companies are there whosoever are using 3D scanner, because it is a costly process, but they are providing services also. And third, for what left is a measuring instrument. And to the newly appointed engineer, what the company, because they need to do copy. Let's say I'll take one example. So let's say I hope we'll come to the presentation again. I hope this is visible. No? So by taking this, so they will just give, let's say this is A company, this is manufactured by the company A. So this is one tiffin, and company B want to duplicate it, and they are not going to, because it is a small company, they are not going to you use that 3D scanner method. They are not having image tracer are there. So they just put this vernier caliper, and they just hand over the component, and what the designer need to do, he need to measure all the dimension, and he will design the things in the software. So वर्नियर कैलिपर, तो इट इज, तो ये मैं वैसे भी जब जब कभी भी व्हेन आई वाज इनवाइटेड टू एनी ऑफ द कॉलेज, तो मैं ये क्लियरली वहाँ पे बच्चों को बोल के आता हूँ, टीचर्स को भी ये बोलता हूँ कि जितना भी हो पाएगा बच्चों को मेजरिंग इंस्ट्रूमेंट्स पे, बिकॉज वी आर फेसिंग वन इशू दैट if we hand over the vernier at the very first day of interview, students are unable to justify it, what the function of vernier caliper and what the micrometer is, what is the basic role. So I just put a question, can 19.21 dimension measure by the vernier caliper? You can measure with the vernier caliper. They said yes sir, least count is 20, we can measure 19.21. So because they are not having a very good fundamentals, so I just repeat that students must be having very good knowledge about the measuring instrument, because every industry in the 70 to 80% industry, Indian industry is based on the duplicacy, and they just copy the things of other companies, and by having copy they are following reverse engineering method, and they will not going to adopt image tracing, 3D scanning. They are not having two component drawing, because it is lying with the same company. Because I'll again take the example of this tiffin. So its original dimension is lying with the company A, and company B is unable to get all the original dimension. And by having concept design, they are not even ready to make any new concept. So they have to work with the measuring instrument. This is the only one tool available. So by having a measuring instrument, so measuring instruments students को मालूम होगा, तो they can be easily able to duplicate it. They can be easily make a new CAD model, new designed model. Then the company will go forward for the even subtractive or additive manufacturing, depend upon whatever sources they are having. So measuring instrument, and once by the all modes, these are the possible modes by having design file, because design file is the prime requirement of 3D printing. If we are not having design, and I think I clear you about where we can and how we can get the design file from any source. Either I repeat, either from the concept design or from the component design, and from the duplicacy. Any question, sir? Please, you're free to ask, because then I can move further. Uh,
So you
okay.
can
Please
move
carry
further,
on,
sir.
sir. Please
Carry on,
carry
sir.
on.
Thank you, sir. Thank you very much. So now, uh, the concept design, I think I clear you about the use standard of the component. Just a CAD model was how to refine what is the prototype, how you will relate those all concept to the testing to the concept design. So there is a one small video again. What is the need of design change? Design change करना क्यों है? So this is a small video again. Please see this. So in this small video, I just try to clear what is the need of design and what what is uh, actually requirement of the company to have a new design. Because if the company will not present you the new model, so evenly a day by day it will decline. Like the simple example, Nokia in the time of 2006 to 7 and the C in the up to 2010, they think that no one is going to beat them, because they hold more than 90% of the share in the market, and they stop trying or stop launching new model. Immediately in 2011, Samsung launched a new mobile with a touch screen. So as of now, they pick a revolution in the field of mobile phone, and by the 2019 they have Samsung developed more than 750 models, different models. And a day comes in 2020, nobody knows what Nokia is. And this is the need of design change. And now the Nokia started changing its design, and they're starting putting new models to the market, but nobody is going to recognize because there are more models, more companies are available. So this is to sustain in the market. So every company is looking to change something. So immediately after 2 or 3 months, they will launch a new model of car, new model of mobile phone, new model of laptop, new model of LCD, TV, cooler, fridge, refrigerator, everything. So it is a need of design change. So that is a basic requirement, and at the back end, I'll proudly say that only one engineer in this universe is available to have a very creative mind, that is a mechanical engineer. So if mechanical engineer, I'm not dominate all other branches, but to have a very good idea about the concept, how to develop a model, mechanical engineers play a very good role for the industry. So students can fit anywhere in any of the industry, but they are after having a mechanical engineering, so student just targeted about this. I just want to work with the industry where they are manufacturing cars. I just want to work with the service industry, but there are number of companies are there where the students can directly be joined by having this core knowledge of mechanical engineering with the design. So I just demonstrate something about the, and by taking next, I just demonstrate something about this subtractive manufacturing. So after that I'll finish it because I've left with them very few slides. So in the subtractive manufacturing, now I'll clearly understand you the basic process planning of the industry. So I have just put up the chart over here also. Even also because I know you are working with the cell phones, so it is not clearly visible. So I just make it zoom so clear you all better understand this process planning in the industry. So in the process planning, we just start with the start of the. So this is my company and how we are working. We just start with the engineering drawing. This is the 2D drawing. We will get a 2D drawing, like let's say from the JCB, and by taking this 2D drawing we need to work CAD model. So whatever CAD model we have just make. So another one target is to the weight reduction. We need to take care of the weight, and every calculation we may done over here only. So I just open the same model again. So how we are working, like this is a crown, and I just assign the material to this. So because we have all the materials are available, I just apply this material properties. So let's say this is of steel material. So I just apply a steel material to this, and so in this it will give me the mass properties of this. So it will give me the mass. This model is of this much kilogram. So instantly I'll get mass. Weight calculation is the major. Then companies are looking up to the 10 to 15 grams of the reduction of weight in the plastic component. In the forging component, we are targeting up to 100 grams. If we are able to reduce 100-gram weight in the component, so the company salute us, because the materials are very costly, and the production is in on the daily basis. As I told you about the 2 million axle we are producing, and out of 200 million axle, uh, 1 month, if I save just a 50 gram of the material, so it is a very good for the industry as well for me also. So just having weight calculation, we will do virtual assembly. So I'm not going to assemble anything on the CAD because it is very easy, because we are having different components and we can just virtual assemble all those components. Even we can check the working in this only. So that is possible, but it is a little time taking. I'm not going to show you virtual uh, and mechanism design, but it is possible. We can design all the mechanism and we can virtually check the assemblies part, global clearances, global interferences. We can check in the software only. If the model fails, we can recheck the model, CAD model, and we will redesign it, because if dimensions are not good, that is why it is not able to fit. It is not able to work in the. So once it will fix, and then we will go for the die development again, because this is very important to have a die, because 3D manufacturing or 3D printing हम इसलिए करते हैं because we need not to take care of the die. This is the very good example, and that is why I just want to clear you about the die. And in this die, this is the costly process of the entire component manufacturing. Let's say one example, if the component cost is 5 rupees for any component, so it die cost is 5 lakhs. So we just think it of, if the die costing in the 3D printing, we just save out the die cost. We need not to manufacture the mold. That is why we are focusing the rapid manufacturing. So in this die development process, we need to design the die. I'll show you one example to this model. Suppose I have already designed the die to save a time. To this model, if the die is basically male and the female part, I just open this die. So sorry, I'll just try to this is my part, and I just try to, oh sorry, but um it's fail, but no problem. I just make it again. So give me 1 minute, please. Uh, because component is missing from the library. This is the size of mold. So in this, I just want to create a workpiece, and this is mold box. So mold box, I think we all know this is the mold box, and I just in this to take care of time, I just place uh, going to place an automatic mold over this place. So in this case, so we are having, sorry, it's not working, no problem. So there is a component failure problem. Oh sorry, I just reference region is missing. Okay, clear. Give me 1 minute, please, sir. Yes, I just delete it out. How we can able to make a mold? So I just want to install workpiece, and now I just want to have a workpiece with the 30 mm offset from the previous one. So it just give me that model, and I just, no problem, I just create manually. So this is mold box. So for creating any mold box, because automatic is not working because it is failure due to some glitch, no problem, so we can make it manually. So this is the size of, so in the industry we are working with a Hasco and Futabo standard of mold box are there. So you can check that Hasco and Futabo standard of mold box. So I just assign the size of mold box. My mold box size is this much, and if my draft angles are correct in the so that I can only be able to make a parting line. This is the parting line in the blue color, it will show me the parting line, and out of that I just want to have a parting surface. So in this, so it will show me the parting surface. I just want to have a parting surface by this place only. So now say okay, and this is a parting surface, and right now I just want to partition the model in two volumes. I just click it, and I will partition, sorry, I have to partition the volume and this volume, and I just partition this with the help of this mold. And for time being, I just hide it, and out of that I want to extract it because it is still lying in the library. I just make it open, and this is the core and cavity. Basically in the forging, this is called die and punch. This is the entire output of this product, and to make that component physically available with us, we need to manufacture this die. And what's the power of this die? We just save this, and I just try to open it also, so you can easily be understand, like this is my die. I just open it to the 150 upside, so even also 150 downside. So this is how now we will fix that die in any of the CAD software. So we just make a die, and this is the component actually. Now I think, I hope you clearly understand. Right now this component is not required. If we want to manufacture this component, we have two ways. If we want to manufacture this in the quick way, we have rapid prototyping. That's a today's topic, prototyping. And other one is a additive manufacturing, other one is a subtractive manufacturing. And if we want to take this model in the subtractive manufacturing, we need to take a die block from the market. And for this die block, it, if we talk about the cost of this die block, for that its diameter is near about 100 mm. diameter, and for 100 diameter crown to 300 diameter crown, this die block cost more than 30 lakh rupees, because it is undergoing the high pressure. It need to bear high pressure for the forging. I'll give you one example from the videos also. So in my industry, so sorry, lot many windows are open. In my industry, we are working on the robotic forging. So I just fast forward the video, so that it can be easily make you understand what the forging process is. And in my industry, by this way, uh, we are heating up the billet. So this is the raw material. Robots are working. So this is the raw material. I just this is the this process is called billet heating process, and we are using induction heating. So if sometime free time you want to visit my industry, you're most welcome. So robot will pick that heated billet and it will place behind that hammer. And in the hammer, it is the die basically. This is one and this is two that I have designed in the software. It is the die, and once the hammer press, these are the guide pillars. So once it will press, it will make the component in one shot. Axle is ready within a one shot, because the capacity of the hammer is 2500 ton robotic hammer. So it will take the component from that mold and it will place in the bin. So component is ready and the process again repeat. And it is the same die, that whatever we have designed over here, that is the same die. And whatever component we have look in the daily life, they all are produced with the help of die. Even a 5 rupees soap also, to the candy 1 rupee candy also, they all are produced with the help of die. And if we know how the die is working, so we can easily work anywhere in the industry. Let's say one simple example is there again. So what's the role of this dye? Now you can check it. A soap manufacturing industry, they are also having dye. It's the male and the female part. And what next to this process? Once we have designed that dye, we need to take that dye to the subtractive manufacturing. Additive manufacturing is a little topic, but before you go to the additive manufacturing, you need to take care of the subtractive manufacturing. What is the actual need of additive manufacturing? What is the reason behind using additive manufacturing? If additive manufacturing is not there, industries are lacking, or industries fail to spend number of times, number of cost, machinery cost, worker cost, everything. And everything is produced with the help of die. And if we entirely see the industrial automation 5.0, so it is the plastic manufacturing industry. So in this manufacturing industry, they are manufacturing these tools, and again the die is working inside the machine. No human being is there. Machines are automatically take material, so they just melt it out from the furnace, and they just put up in the die with the high pressure. It is an injection molding. So we can, this is the die again. For the means to say that 97% of the component from the daily life, they are produced with the help of die. And even also, if we talk about this spoon, this uh, 5 to 2 rupees spoon, they are also, it is also produced with the help of die. It is a power of die. So that is whatever I have done here, that is the die for the same model axle. And now I have to make a subtractive manufacturing, because I need to machine this die. To machine this die, I need to be very clear that I have to put this machine for the CNC programming. And I told you about the block cost. It is near about 30 lakh block, and along with the CNC machine. And now I'm going to put this block in the CNC. So what happens there? I have checked everything. I need to manufacture the parts by this software only. So I'll just open again how the CNC programming is working. So I just open another software again. So I just clear you about that. Sorry. This I have open product designer. So I just open and next. So give me 1 minute, please. 1 minute, sir, please. This is the role of that die. So I'll take this die in the software. So I'm not going to put anything in over here. I just simulate it. I just verify. We can assign every tool, speed, spindle feed, depth of cut, everything we will mention here only. We just check, calculate it. So this is how we can able to see whether this die is okay or not. But after having this much, so it will cut this die. So this software will cut that die basically on this. We have ready the program, and after reading this program, I just make a program like my machine is three axis machine. I just put up and this is the actually G codes and M codes, whatever we taught to the students in the semester. So we can able to ready this much code files with this much codes within 2 seconds. So this is the number of lines. It is actually the CNC program or the VMC program. This is actually running behind the subtractive manufacturing. First of all, I need to take care of the component. I need to design component. I need to design die. I need to make a program. I need to transfer this. Now, what I have to do? I will take this program in the pen drive, and I just take this program from the pen drive to the machine. Once I transfer, the machine will run as it is, and without any. That is why it is called error-free manufacturing. This is also be named as a digital manufacturing because everything is digital right now. I just take this program in the pen drive, and once I'll shift this program in the software, so it sorry, to the machine side, it works like same. So I'll give you one video about the milling. So this is actually happening. So I'll fast forward it. This is someone ready the program. So it is okay. So they have make just slot and just fillet cutout. So once this program, one how this program is running, the machine will run 150% exactly same. This is the phenomena of subtractive manufacturing. It is a time taking, money taking, and the manpower taking, sources taking process to make a sample. So if we need to have a sample, we need to work with this kind of uh, you can say the process. And and it is because this program is 100% justified program, and it will not going to impact on the machine or the cutter or the any parameter of the software. This is something about that subtractive manufacturing. So whatever we have learned about the subtractive manufacturing, this is NX. This operation is the end process of the subtractive manufacturing. So that software is ready. That 2636 number lines of program in a 2 seconds. This is a subtractive manufacturing and taking next. So before, this is the die development, but this is not actual die development. This is the die development in digital mode. What I have designed in this place. So it is the digital mode die only. So they are not designed the physically. So once they have designed the die in the digitally, then they will make a prototype. The next concept is the prototype. This is the 3D printing, and it is the today's topic. Now, after I think 1 hour and 10 minutes, now I am going to start the today's topic. I hope it will help you better understand what the basic phenomena of the today's topic. What running actually, what are the disadvantages if someone, let's say, want to have a simple sample. So by having subtractive manufacturing, they need to make a dies out of that, and nobody is going to let's say, after die, if someone wants to change the component, it is not possible to change the component. We need to change the entire die, and it is a very crucial process. And in some of the cases, die can be changed, or in some of the cases we cannot change the die, and it is entirely wastage of money. That is why prototyping is here. So right now I am going to take you about the prototyping process. Now you can easily understand that is prototyping is having three kind of again prototyping. First one is the hand molding, or you can say that the hand modeling. So in the hand modeling, so we will ready the sample in the POP. It's a plaster of Paris, wood and clay. So it is popularly known for the earlier methods of the prototyping. Plaster of Paris, wood से बनाते थे prototype and clay. Other one is some companies, they are ready to spend they are ready to spend sampling. So we just uh, I just clear you, by subtractive manufacturing is again of two kind. So subtractive manufacturing is we can be able to manufacture the model with the help of die. This is one method. Even also we can manufacture the component. It is direct machining on the component. I'll take one
Sir,
example
I
of.
have a question, please.
Yes, ma'am. Yes, ma'am. Please.
So the thing is this, can you tell me the strength what 3D printer is making? Will that be of good strength?
Yes, ma'am. Yes, ma'am. I'm coming to the topic, ma'am, again. So,
Okay.
yes, yes,
Can
ma'am.
you roughly tell me the cost of this 3D printer?
Ma'am, in the market, if we talk about the education printer for the education, they are start from the 3 lakh rupees. So commercial
Okay.
printers are 35 lakhs, 40 lakhs plus.
Okay, fine.
Yes, ma'am. Yes, ma'am. So subtractive manufacturing, ma'am, can I continue?
Yeah, please
Okay,
continue.
ma'am. Subtractive manufacturing is two kind. One thing is by having dies, and other thing is by having component direct machining on the component. So in the direct machining, so let's say someone designed this cell phone and they just make a CNC program on the cell phone only, not on the die. They just put a aluminium block behind that CNC. They just cut it and they just get a model. So it is a subtractive manufacturing process in the prototype. This is also available, but for that again expertise is required. Someone who is having good experience in the CNC, they or he or she can be able to work, otherwise not possible. So in this case I just clear you, so how we have started in this. So we just want to check the material removal. This is a rough material we left for the finishing, and I just want to, after this I just want to have a play. So in this case, the robot will cut that because it is a 6 foot height is there. So it is cutting that. Again, we are directly manufacturing on the component. So this is the robot. Basically, it is popular with the AI programming nowadays. So this is the program actually. So it will cut that model one by one, step by step. It will cut, and it is reading that program. So we will transfer this program, and once we will transfer this program and robot will cut, it will instantly get this model or give this model to us. So that this is the second method of prototyping. It is the subtractive method of prototyping. So another one is additive manufacturing. This is the today's topic. So in the additive manufacturing, it is 3D printing and 4D printing included both. So I'll clear you something about the clay molding also. These are the some of the model designed by my team to have a clay models. This is a model by the POP. We have designed some brake caliper. We have designed some other component for the industry. So this is some dashboard for the company. So it is a arm rod. We have clay model. We will make it hand molding with the help of clay molding prototyping. And these are the 3D printing technologies. So I'll clear these all later on because we have affordable and accessible. Another one is the metal printers are there. So in this we have metal extrusion, wet polymerization, powder bed technology, material jetting technology, binder jetting technology, powder bed fusion is there. So popularly ये जो methods है ना, FDM, SLS, SLA, DLP, these are running well in the industry. That is, I have marked it as a green so that they are affordable and accessible. So before we go to the prototype, so अभी तो छोटा सा टॉपिक बच गया मेरा. I'll take only next 10 minutes. तो ये क्लियर हो जाएगा. Prototype is a simple visualization of the product to test the concept. So like someone designed this model, so they need to design, and it will not instantly or directly go to the machine for prototyping. There is a one media that is called STL. I repeat it. So it is the only format available for making a 3D print possible. This is STL. It is called stereolithography. We need to change the design to the STL. And what plays the role in the STL? So you can be have the STL file. So as I told you, we can print it out. I'll again go to the topic again. So now I close everything from this and I just open a model. So we have this model and now I just want to print this model and directly it is go to the printer when I'll select the printer and say okay and say okay. But I know because I am working on the same from past 10 years. So I know the basic fundamental, but I would like to clear you about the quality of the prototype as the question raised by the ma'am. The quality of the prototype is depend upon the both modeling techniques, or we can say that the design intent, the type of STL file, the type of STL file, and just hold for one moment, please. So sorry for interruption. So now, sorry, I'll again come to the topic. I'll close everything. So the print depend now. The question raised by ma'am, we are there only. The question raised by ma'am is uh, what is the strength basically, and the strength depend upon the intent of your design, quality of the printer, and the quality of STL file. And once we when convert to the STL file, any in any of the software, any of the CAD software, STL file is available. And other name of the STL file is known earlier. It was known as the standard triangle language. So nowadays it is called a stereolithography. So this is the only format that is readable by the 3D printer. So I just uh, how to make a STL file. I just save a copy. So I just make a save as a stereolithography format is there, STL. So once you will STL make a STL, it will customize export. And what major plays the quality of the build quality of the prototype is the chord height. So we need to take care of the chord height. What is chord height actually? So in this case, we will mention the chord height in 0.001, means 1 micron. I would like to add a chord height as a 1 micron. It will immediately calculate the minimum chord height. So it is available. It is the every aspect of the software. It is available in the software. So this plays a very good role to have a build quality of the prototype is the STL file, quality of the STL file. So there are the two modes of STL file. One is a binary STL file and the other one the ASCII STL file. And chord in this case, if the chord height is let's say 10 microns. So in my case, I just mention a chord height and it is giving me the chord height as a, I'll show you what chord height is actually. So it is giving the chord height is 9 micron. We left this 900. So it is up to the 9 micron. I simply say apply and okay. So I would like to share. So if you notice it, so at the bottom end, I just make a screenshot of the same and I'll paste it onto this slide. So what it is giving a warning that it has triangulated that model and 40,876 triangles have been written in the output file for crown.stl. This is the final output, and if the triangles are less, let's say triangles are 10,000, so the build quality is not good. If the triangles are 20,000, build quality is fine, better than the previous. If the build rectangle triangles are the 40,000, build quality is fine. If the triangles are 80,000, build quality is super fine. So it is all depend upon that the type of STL file and the type of printers and what it has done, it has triangulated the model in small. If I zoom in, so it has just made a triangles. You can check it. These all are the little triangles. And what chord height is actually, so we can check it. So I'll clearly explain you about the chord height. This is, let's say, cylindrical surface, and this is the triangle line of the triangle, and the distance between the surface of object surface to the line of triangle is called chord height. Now we assume to be this chord height as a 0.001. It is 1 micron, means to say that the height of this, and we can say that the distance from of this line to the surface is a it is not visible in this CAD file, but I hope maybe you got my point. It is clearly known that the distance of this line to the distance of surface, actual surface of the model, is 1 micron. This is the chord height. And it, as finer my chord height is, so as build quality is the good in the prototype. This is the role of making STL file in the prototypes. So I hope you cleared. I am in the 42 slides, so I have another 30 slides there. So up to this, any question? If someone want to ask any question, I'm ready to answer, so that I can continue next.
Sir, I have one question, please.
Yes, ma'am. Yes, ma'am. Please.
जैसे आपने अभी बताया कि जो प्रोटोटाइप हम बनाते हैं, ठीक है,
हाँ जी मैम.
आप प्रोटोटाइप क्रिएट करें, अब उसकी जो स्ट्रेंथ होगी वो ठीक है कि आपने बता दिया कि आप डिफाइन करते हैं एंड
Right,
विल
ma'am.
गेट द स्ट्रेंथ. अब मुझे ये बताएं कि जो स्ट्रेंथ के लिए हमने मटेरियल डालना होता है,
हाँ जी.
लाइक यू गिव द स्ट्रेंथ, अब मटेरियल वो हमारा सॉफ्टवेयर डिसाइड करेगा 3D प्रिंटर का कितना डालना है, कि हम डिसाइड करेंगे
No,
फ्रॉम द
no, ma'am.
प्रोटोटाइप विल कम टू द फाइनल प्रोडक्ट.
नो नो मैम, जो मटेरियल है ना, इट्स अ
हाँ
वेरी
जी.
गुड क्वेश्चन मैम. ये भी मैं क्लियर करने की कोशिश करता हूँ. तो जस्ट गिव मी अनदर 1 minute, बिकॉज दे ऑल द सॉफ्टवेयर आर रनिंग ऑन द डेस्कटॉप्स. सो वो हमारे वहीं पर रहते हैं. अगर मेरे पास मैम यहाँ पे इंस्टॉल हो जाता है, तो मैं आपको डेफिनेटली क्लियर करता हूँ आपका जो क्वेश्चन है. सो बट इट इज अनेबल टू लॉन्च. मैम जो मटेरियल का क्वेश्चन रहेगा ना, तो
जी.
वी कैनॉट कंपाइल. तो इट विल गिव मी द वार्निंग एक्चुअली कि योर मॉडल इज, बिकॉज आई हैव वेट ऑफ द मॉडल, आई हैव
Yeah.
ऑलरेडी कैलकुलेटेड द वेट. सो एज पर द वेट, जब व्हेन आई विल टेक दैट STL फाइल इन द सॉफ्टवेयर, so it will give me the build time and build material, how much sport material is going to consume and how much model material is going to consume in the cubic centimeter. So it will give me, and one cartridge, it include 1000 cubic centimeter material. So as we are working with FDM, so software will give, 3D printed software will give the before printing, it will give you the warning actually, or give you the exact amount of material consumed for that same prototype. So
Okay, fine.
yes ma'am.
Okay, sir.
So,
Thank you, sir. I got it. Thank you very much.
thank you, ma'am. Thank you. Because, ma'am, the software, I am unable to install the software in the laptop, but I'll sure, I'll take a screenshot once I'll reach to the industry by Monday morning. I'll take a screenshot and definitely forward to you, ma'am, and how we can calculate and how it's giving a warning to us. So,
Okay.
and
No
ma'am,
issues, sir. No issues.
thank you, ma'am. Thank you. And,
The
ma'am, there
lecture is
are.
actually very interesting, so I'm engrossed into it. So that's why I'm asking question again and again.
थैंक यू मैम. थैंक यू मैम. आई एम फीलिंग वेरी प्राउड कि आप क्वेश्चन पूछ रहे हैं, तो ये मेरे को अच्छा लग रहा है. थैंक यू मैम.
Thank you. Thank you.
And ma'am, there are some common methods of additive manufacturing. First of all, a selective, it is called SLS, selective laser sintering. And so nowadays it's a metal laser sintering also available. Electron beam melting is another process. So in all the processes, what they have done, they have just a fuse. They need to fuse the material and they need to join the material. Fusing is another task. Joining of the material is another task in the 3D printing. So they just fuse it and they just need to have a join it. And for all these parameter, they have some sort of use for some, in some of the cases they are using electron beam melting for fusing of the material, and they are using resin. In this LOM, is a laminated object manufacturing, they are using laser for the fusing, and they are using lamination for the binding. So in SLS, selective lasers, in they are using ultraviolet radiation for fusing, and another resin for joining. So this is all about the fusing and the joining. All technologies are working, but basic phenomena is the STL file and the design file. So in the fuse, now I'm going to elaborate about the fuse deposition modeling, because it is the super far advanced than all the modelings of this 3D printing. So clearly about, मैम again your question है, यही जो आप strength के बारे में बात कर रहे थे. So these are some materials like ABS plastic, PLA, so polyamide, glass filled polyamide. We can be filled nylon with the glass filled polyamide. It increase the strength. And ma'am, even you can check it out. We have PEEK. It's a ether ketone material. Then PETG. It's a polyethylene terephthalate glycolone material. So these are some composite materials, carbon fibers, photopolymers, and polycarbonate. These are the smart materials, wax, steel, all the materials you can put up in the like ma'am, titanium and cobalt, magnesium. We can all already put all this in a D. This process is there, DMLS. It is called direct metal laser sintering. Even laser sintering is also will metal. You can directly print the metals part in the printer, so we can composite those metals, and we can make a alloy of all the metal. We can directly put up to the printer, and it will fuse that material, and it will bind together. So that kind of things are possible nowadays in the 3D printing. So smart materials are also there. So it is all about the 4D printing. So in in all the materials, so 150 plus kind of materials are available nowadays for 3D printing. uh, so basic phenomena is same. So another one is the resin base. I already clear about SLA and SLS, MLS. It's a MSLA. It's a masked stereolithography for the commercial size printers. Better surface finish, best strength, less printing errors are there. So this is how, ये मैम, it will work ulta. The inverse में work करेगा. This is a resin tank, and we will store the resin in the tank. So this is a machine table. तो ये सबसे नीचे zero पे touch करेगा, and the light source light beam will fall, and it is a digital light DLP. It is a digital light printing process. So light will fall, and जितना resin पे light fall करेगी, that resin solidify, and जब it will solidify, it will go up. Another fresh resin comes, and again the light beam fall, and it will solidify the, then it comes to the next step, and whatever layer size is there in the printer. So in generally what we are having a fine quality printer is there, so we work for in the range of 250 microns to 314 microns. So we can be able to easily work in the 254 microns to 314 microns. But the least count of the printer is 214. Means to say my printer one layer size is, least layer size is 214 micron, 240, sorry, 254 microns it goes up. So this is the SLS in the selective laser sintering. In the FDM, the table is stationary and the nozzle goes up. Once they will modify or the table goes down. So once one layer, it will modify one layer, table down, another layer, again table down by 254 microns. So in this process also, table move upside, and once it will solidify the layer. So another the fresh layer of the resin comes, then the again laser beam fallout, and basically ma'am, all this is working upon the layer size. As I told you, I'll give you one videos also, so it will clearly explain about the FDM, so that we can easily understand about that other processes. This is simple. means STL. So I'll show you the tool also. In this video, they have converted that 3D model. So we can keep this model in any orientation. So there are the six to seven possible orientations are there for to build any model. So my time taking, how much time is going to take by the 3D printing process is all depend upon the orientation. Now it has divided all that STL file into layers. These are the layers, and once I'll transfer that STL file, the electron beam will or the electrical beam will passes through these layer size only. It will not go out of this layer size. So when the beam passes or beam react with this much layer size, it will solidify that much resin. So again, this is the second layer, and in the second layer, or the this is the support 10th layer, it the beams comes from these areas, and it will solidify this resin. It will again stuck with the previous layer, and as it goes up, it will build a model. This is the basic phenomena, but it has divided the model into the layers, and layer size, printer size is depend upon these all are the tool path for the 3D printing machine, and nothing we need to worry about. We just design the file in the computer, make a STL file. Once we transfer the STL file to the printer side, it will immediately calculate the program. We need not to ready the program. And once we transfer the program from the computer to the machine side, so it will build the model as this is a FDM. So in the FDM, so there are the two rollers. It will material is available in the form of wire. So wire will go through the roller, and roller will push the material inside the nozzle. And in the nozzle, this is the nozzle, and in the nozzle there are the heating elements. In this side, I'll previous this try to make it. This is the basically casing, and in this casing heaters are available, and heater will heat up the metal, and it will pass through the tip of this nozzle. So this is fast forwarded video. So it is working layer by, and in this case table goes down. My nozzles are remain stationary, but the table goes down, and it will build the model layer by layer. This is a phenomena, and whatever we have ready in the CAD and we transfer, we can transfer the file from that. This is FDM. So layer, in this case, layer quality is 0.254 microns, and and this in this process it is inverse. In this process, bed goes up, and the light falls from the downside. So this is the resin tank. Rest all the resin we can use later on. This is the recyclable resin. And in the FDM, I clear you about the FDM process. So this is the filament in the form of wire. These are the heater. When it is passes, it will build layer by layer. So I clear you about the video also. So these are the some important components of the 3D printer. So first one is the support and the model, because for the under passes areas or undercut areas, we need to have support. Let's say I want to build this phone vertically like this. So ये गिरे मत इधर उधर जब ये build होगा, तो for that the machine will build a layer of support material first on the base. So there are the two materials, support and the model material. So support material workbench पे रहेगा, like in this figure. So this is a build plate. So build plate means in the workbench. So there are the first 9 layers बनेगी for the support material. तो वो model को hold, it will hold the model, and rest all the other layers are the model layers. So they will put the model layers for those all. So we are having support and the model nozzles, support nozzles and the model nozzles. These are the nozzles, and in from out material come out from these two nozzles. Other one is a resin tank. It is for
Sir, one question, please.
yes, ma'am.
The resin which you are saying and the jewelry casting resin are both the resins are same or they are different?
No, ma'am, different. As per the composition, ma'am, in some of the companies, they just want that if someone want to have jewelry design, So I missed that jewelry design part also. So they just need to have a pattern. Once they'll get pattern, and by hook and crook they will use any material. Even ma'am, they commonly use that PLA materials. It is a very common material. So it's a polylactic acid, and that material they can use for making a prototype.
I'm
Once
saying
they'll,
ज्वेलरी कास्टिंग रेजिन मींस जो रेजिन से हम ज्वेलरी कास्ट करते हैं ना,
yes,
वो
yes,
उसमें भी रेजिन यूज होता है आजकल, एंड द रेजिन व्हिच यू आर सेइंग दे आर डिफरेंट और दे आर सेम.
ma'am, as I told you, ma'am, there are 150 plus kind of materials are available. So
Fine.
yes, so because in the jewelry, so once we need to, I'll give you one example, ma'am. Just I'll take the help of internet. Uh, Suppose, ma'am, like this. Okay, we'll take the example of this.
Fine.
In this case, this is the real application of the model. It needs to be undergone to the some load application, or this hand. This is a prosthetic hand. It needs to be go to the that some holding application. It needs to hold something. That is why if the material is not good, strength of the material is not good, it will lose that object. So for that cases, we need to have good material. It can be good composite resin also, but in the case of jewelry design, we just need to have pattern only. Once we are
Yeah.
having pattern, and by the good material or by the bad quality material, so other one is the casting process. They just casted it out, and the jewelry comes from the gold or silver or platinum.
Yeah.
But before that, material is not plays a very good role in the casting, even in the pattern design. So they can be used either like this model, ma'am. So in this model, strength is the basic ratio, like this spot. Strength is the basic criteria. So in this case, we are not going to compromise in the material. So if we just need to have a pattern, then we can compromise with the materials.
Fine, sir. Got it. Thank you.
Thank you. Resin brushes are there, heater, they will heat up the filament up to the 300 degrees Celsius. So these are the blower to maintain the continuous in house temperature of the 3D printer. It works near under 75 to 85 degrees Celsius environmental temperature, 300 to 350 degrees Celsius nozzles temperature for heating the filament. This is a machine table. It is the machine cartridge, and material is available in the form of wire in the case of FDM. So these wire goes to the machine side, and the roller push the wire in the nozzle, and the nozzle will melt or the material, and it will diffuse layer by layer onto the metal side. So one more video.
A rapid prototype starts as an STL
Again,
file.
sorry, this
A
is
rapid
clear. So now in this is the all about the 3D printing, and in 4D printing there are some enhancement to the 3D printing. In the 3D printing, let's say I have built this model, and it is not if the function of this model is like say flexible, it needs to be a flexible, or it needs to change the color, or it needs to such put up when I'll expose to the high temperature, it needs to change the shape. So for that, they have the advanced material for the 4D printing. So this is the my research area also. I'm doing my research in the 4D printing also. So in the 4D printing, it involves the creating of object to change their shape to the property behavior over the time. So stimuli such as a heat, light, humidity, and what it does actually, this is phenomena is the same. We need to design the model in the CAD. We need to take the STL. We need to print by instead of plastic ABS. We need to take that with the help of smart materials. and once it is exposed to the heat, it will change the color. As I try to present in the GIF format, it will change color or shape, and it is basically the 4D printing. This is the form of additive manufacturing only, and these are some common materials, just shape memory polymer. So we are having hydrogels, liquid crystal elastomers, so piezoelectric materials, the thermo-responsive polymers. So they are the newly surged and newly advanced materials for the 4D printing in the additive manufacturing. Lot many research and open area are there for research in the 4D printing sector. So what I missed is about the use of this in the medical application. So now you will clearly, all will clearly understand the process. I just try to explain, where I am nothing in front of you all teachers. So, but I just explain you about the role of 3D printing in the uh, manufacturing industry in the medical sciences. Like this, I'll show you one video. So in this video, let's say this is one patient, this is artificially created one video. So this patient by the accidentally उसका बैकबोन टूट गया, सो ये क्रैक हो गया. So in out of this portion, now the doctor will sit with the engineer. They have guided that if the engineer, if the patient need to survive, so we need to install this component in the backbone. अब डॉक्टर को तो डिजाइन करना नहीं आएगा, so doctor will sit with the designer, so he guide to the engineer that you need to design this component, and instantly CAD comes. So we will design this model in the CAD, and once we have designed this model in the CAD, immediately we'll transfer the file to the 3D print. As I told you, 150 plus materials are available, and in this special printer, this is bone and vessel printer are available. This is how it will work layer by layer. This is one layer, and in that printer there are two material. One is bone material, other one is the vessel material. So one will print a bone, other will print a vessel. So ये मटेरियल कैसे बना, तो वो उन्होंने मटेरियल साइंस जो करते हैं, दे नो बेटर कैसे उनको बना के कंट्रोल सिस्टम सेरामिक पार्टिकल्स को मिला के मटेरियल बना लिया. दिस इज द वन लेयर, एंड अदर लेयर में क्या होगा कि नोजल विल क्रिएट अदर लेयर लाइक दिस. मैम, दिस इज अगेन योर क्वेश्चन. दिस इज हाउ वी कैन इवनली कंट्रोल द डेंसिटी ऑफ द फिलिंग डेंसिटी कैसे होगी, एंड फिलिंग क्राइटेरिया कैसे होगा उसको फिल करने का. जितने डेंसिटी अच्छे पे हम उसको फिल करेंगे मटेरियल को, उतनी गुड उसकी स्ट्रेंथ आएगी. दीज ऑल पैरामीटर वी कैन कंट्रोल इन द सॉफ्टवेयर फॉर 3D प्रिंटिंग. कैड सॉफ्टवेयर में नहीं होगा, ये 3D प्रिंटिंग का पार्ट है, मतलब इट इज कंट्रोलेबल. दैट पैरामीटर इज अंडर कंट्रोल, वी कैन कंट्रोल दैट पैरामीटर. एंड यहाँ पे वो रेडी हो गया पार्ट. वंस इट हैज रेडी दैट पार्ट, so now we can put up that part from the table and we can put up to the patient. यहाँ पे उसको डाल देंगे, and we can easily check the simulation also whether it is good to flow the blood or not. Even it is blood is flowing well. This is the CFD. It is called computational fluid dynamics. So with the help of CFD, we can easily understand whether the flow of the blood is good or not. Even also we can identify if we install this component to the patient, so where the load actually comes. This is computer aided engineering, CAE. We can easily be able to calculate where the actual load comes if we have replaced that component. So these are the two areas, two bones where the load comes, and we will add another sort of support to these two bones. So once we have added those support to the bones,
Is
so
it
now
possible, sir, is it possible to design, like, you are creating some part. Is it possible to create exact structure like a bone?
yes, ma'am. 3D scanning, ma'am.
Okay.
Yes.
Fine.
As I told you, matlab, how we can get that model. So this in this I clear you about how we can get the 3D model. It is with the help of 3D scanner. We can scan that. I'll clear you in the next video also. So it is something related to the same. So like this. So they have scanned the bone. So from the patient, they have just scanned the bone. They have alter as per the need of change. They have alter the bone where they want to reduce the size, where they want to increase the size. They have just alter. This is the resin based tank. They just place, and again from the STL file they just pick. So this is the light beam falls, it will immediately solidify the resin. So once they will solidify the resin, it will go up upside, and at the final stage they will ready the bone like this. It is the actual, it will behave like the same bone. If we'll put in front of any dog, he is going to eat that.
Like you are saying, there will be no need of plates in coming time. These bones can be installed.
Yes, ma'am, this is happening in the world right
Okay.
now. We can, you can see it. These things are happening in the industry. No
Okay.
need to have further more plates. So we can everything replace with the help of this 3D printing. Actual bone, this will behave like actual bone is there.
Okay.
Yes, ma'am.
And see, the people are rely more titanium plates when it comes to the plate part because they have a good strength. So can we achieve that strength with this kind of
Ma'am,
material?
yes, I'll share you. You just, ma'am, I'll even also I'll share you PPT. You just, ma'am, check it. This PET G, PEEK, and PEEK,
Okay.
PEKK, and PET G material. You can compare the strength. Even more research papers are published on this. So even they have comparison about the metal. A 10 metal plate is weaker than the 10 this PEKK material.
Okay. Fine.
Yes, ma'am. This much strength is already done
Uh,
by the some research scholars.
okay. Fine.
So, and ma'am, this is all about 3D printing, and I'll like further more about the IPR.
Donors
Is
are difficult to find.
one
And
video
what
I
we
left.
wanted
So this is all about the organ printing. This video is available on the YouTube. So I've just copy and paste from the YouTube only. So this is not all about my secret media.
to see
So
is trying to be
so
less dependent
organ
on
storage
organ
needs to be
donations.
multiple.
So with 3D
So
printing, the
they have
capability is
just
to be able
printed
to
the failure
generate
organs.
organs
So
which are
they'll
acceptable
start
to the
working with
recipient
the
are much larger.
once the patient
But
will
we're not
receive
there
that. It
yet.
is all with
We
the
are
help of
moving towards
smart
that
materials
direction.
printings. So even can be hand, and in the 3D printing, the 3D printing market for healthcare is expected to be reach $2.3 billion by 2020. तो ये ऑलरेडी उससे क्रॉस कर चुका है मैम. अगर इसका आप अभी न्यू रिसर्च देखोगे ना, तो इट नियरली क्रॉस टू द 6.8 बिलियन. ये हो चुका है
Okay.
क्रॉस.
Okay. I think 3D printing is more aligned towards CSC also.
Yes.
So yeah.
In healthcare can be defined with through the printing
And ma'am, even
crowns and bits of
teeth
type of
dental
braces
segment.
that could be
So we
printed
can be
for the
make a
customer in
braces,
the office. And the
digital
reason why
braces.
this
This
is
is
a
all
method that
the
is
scanned
fairly
bone. So
economical,
we can
especially
print
for
it
the
out.
patient, is that
Organs print it
you
out.
do
This is the
a
3D
scanning of
scanning.
the impressions
They
of
have
that
just
patient
scanned
and then
that
are able to
immediately they will get a
modify
model,
in an
and they
electronic
will
file what
trace
you'd
the
like
printout.
those final state of the teeth to
So
be. And then you're able
in
to replicate
everywhere where 3D printing is working,
this.
so they are
Also,
working with the
cost
scanner,
minimizing
they are
of
working with
different
the 3D
was
scanner, they are
located
working
if
with the
they're made out
printing layer
of
by
the shelf
layer like
polymers, so
this.
they're not too
So
expensive.
we
From
can
that
be able to
perspective,
build
it's also
artificial
cost
arms,
minimizing in comparison
so
to
artificial
traditional
legs,
prosthetics. For
so
example, in the use
with
of
a
in
good strength,
pediatrics,
prosthetic
which are
hand.
in constant growth, the cost
So these
associated
kind
with
of
that fitting
things
will
are
be
possible
lower. It
nowadays
also will be
with
a
the
rapid
3D printing
turnaround in
process.
comparison with traditional fitting of prosthetics. The second application is bioprinting. The tissue engineering market in relation to 3D printing or bioprinting is expected to have approximately 32% growth in the next few years. The main difference associated with a bioprinting operation and a 3D printing operation is the use of bioink, which is artificial or it could be natural materials and the mixture of those with cells. And when we say artificial, think about polymers, plastics, and natural could be lactic acid proteins, From the perspective of drug testing, bioprinting could offer flexibility in terms of cost efficiency. And what I mean by cost efficiency is animal testing. Animal testing is fairly costly and does not replicate what the interactions of the drugs will be with the human. So having a platform with 3D printing where we're able to replicate what the human tissue would be, provide us one, repeatability for the drug testing, two, lesser costs associated with the drug testing. A lot of studies start with mice or rats, but then to be able to prove that it's truly efficient, you have to go with larger animals and you have to take care of them during the process of drug testing, and it's costly. And with bioprinting, it does provide you a platform to be able to do drug testing without the use of animals.
That is also be possible. And in the 3D printing and the 4D printing, so agar any question, if someone has to put any question, so you are open to ask.
One question, please.
Yes, ma'am.
Sir, what is the, effect of disposing these materials? Like you build the prototype, maybe they are not in use now, then you will dispose them off. What would be their effects on the environment?
Ma'am, they are biodegradable.
The all of them are biodegradable.
No, ma'am, some sort of. If we talk about the resins, so they are recyclable, but some of the materials are the biodegradable.
Okay, fine.
They are adapted by the environment. And if we talk about the metals, so we can also diffuse all those metals, and we can take all those metals to the later applications, but it will not going to impact on any environmental, means it is a, you can say that they will not create any kind of pollution.
Yeah,
Yes, ma'am.
fine.
So without taking much of your time, I'd like to share something about the IPR also. It's a patent because I have my own 10 to 12 registered patents are there in the global as well as in the Indian market. So by having a patent, we are having, because this is a small topic, and now I'll going to close it, because in the patent, so patent already comes from the design. So we have trademark patents, copyrights, trademark. These are the three basic categories of the patent. So patent is a type of legal protection of unique visual quality of the manufactured item. So ये क्या कहना चाह रहे हैं इसमें कि let's talk about this bottle of the Coca-Cola. So ये शेप उसका पेटेंट है. This is the design patent. This is not a utility patent. ये उसका डिजाइन पेटेंट है. अब कोई और कंपनी is not going to design this kind of bottle. And other one is this. This is again, they have designed the new invention. They just take a new invention and put up in the patent, and again they have renewed it. Means customization of the design is possible, and patent एक some sort of time के लिए होता है. तो उसके बाद any company can copy those patents. So these are some example of patent, like Crocs, like drill. This is chair. So this is the bench. तो ये जिस भी company ने they have designed, immediately they have designed some sort of in this case the angle of this is less than this. This is the much angle. So this is one creativity. So by applying a next patent, they have just increased the angle. They need to justify what is not in this and what is included in this. So once they will able to justify, they will immediately be able to get registered patent within the 6 months. But everything comes from the design. This is one thing. So as I told, patent is utility, function, provisional, design. So there are the utility patent. So in the utility patent, let's say this is the coffee maker. And in the coffee maker, if A company is making coffee maker and B company is making coffee maker, and the purpose is to crush the coffee and to make it a good quality of coffee. And we cannot say that this is my patent, because that is under the function, that is under the utilization. Like some companies, let's say, I'll give one example. If some company is making hinge, दो doors पे लगते हैं, तो अगर A कंपनी ने बनाया वो दरवाजा बंद कर रहा है हिंज, B कंपनी ने बनाया इट इज अगेन क्लोजिंग द डोर, तो अब A कंपनी ये नहीं बोल सकती कि B कंपनी ने मेरा पेटेंट चोरी कर लिया. वो क्या बोलेगी कि B कंपनी ने बी वो ये बोल सकती है कि बी कंपनी हैज ईदर कॉपीड माय डिजाइन, बट वो यूटिलिटी क्या है उसका, इट नीड्स टू क्लोज द डोर। तो उसमें दो चीजें आ गई, यूटिलिटी पेटेंट अलग रहता है, डिजाइन पेटेंट अलग रहता है। तो यहाँ पे आपको मतलब वेन एवर यू आर गोइंग टू अप्लाई यूटिलिटी और डिजाइन पेटेंट, तो वी नीड टू टेक केयर ऑफ ऑल दीज थिंग। अब देखना यह है कि मुझे डिजाइन एंड अगर मान लो दिस इज द ए कंपनी प्रोडक्ट, दिस इज द बी कंपनी प्रोडक्ट, अब ए कंपनी का प्रोडक्ट इसने चोरी करना है, तो ये क्या करेगा, उसके डिजाइन में चेंज करेगा, इट नीड्स टू चेंज द डिजाइन। तो अब 80% अगर वी कैन कस्टम कीप द डिजाइन एज अ सेम, 20% हम चेंज कर देते हैं ना, तो दैट इज अ न्यू इन्वेंशन, तो दैट इज अंडर द माई पेटेंट। अब दूसरी बात आ गई यूटिलिटी। अब यूटिलिटी पेटेंट कैसे होगा, अब दिस इज फंक्शन क्या है कि जो हिंज है इट नीड्स टू क्लोज द डोर। अब वो तो ऐसे ही रहेगा, अब कोई ऐसा तो नहीं होगा हिंज, लेकिन इसमें हम यूटिलिटी पेटेंट क्या ले सकते हैं कि अगर मेरे वट एवर हिंज आई हैव डिजाइन, तो दैट इज जब डोर 90 डिग्री पे खुल जाता है ऐसे, तो जब वो बंद करते हैं हम, तो वो 60 तक तो तेज बंद होता है, तो जब 30 डिग्री तक आ जाता है उसके बाद वो धीरे से बंद होगा। So in this case, I have just modified the phenomena, the function of the hinge. That is the utility pattern. So that is my creativity. So in this case, I can change the design of the hinge and I can change the function of the hinge. This is the utility pattern. And design pattern, in this pattern, अब इसमें अगर बात कर लें क्रॉक्स की, तो ये डिजाइन किया फॉर द वन कंपनी, तो ये डिजाइन किया फॉर द अदर कंपनी। अब पाँव तो 5 नंबर का पाँव है, वो तो एक जैसा रहेगा, लेकिन उसमें क्या रहेगा कि वी कैन चेंज द डिजाइन। अब इसमें पैटर्न ऐसा बन गया, उसमें पैटर्न ऐसा बना दिया, तो अब न्यू इन्वेंशन हो गया, 80% विल रिमेन सेम, अदर 20% चेंज हो गया, तो वी कैन अप्लाई द न्यू पेटेंट। दिस इज हाउ द आईपीआर इज वर्किंग। एंड कॉपीराइट, some images, some music, some films, some literature, तो उस पे कॉपीराइट एक्ट लगा रहता है, तो हम उसको कॉपी नहीं कर सकते इफ वी वांट टू कॉपी इट, बिकॉज आप रिसर्च पे सारे वर्क कर रहे हैं, यू बेटर कि अगर हम कहीं रिसर्च पेपर पब्लिश करते हैं, तो वो जो भी जर्नल है वो अपने अंदर स्टोर करके रख लेता है उसको, तो अगर किसी को लेना है तो दे नीड टू पे इट एंड देन दे कैन copy the things from your research paper. That is the copywriting. Other one is the trademark. Like in the trademarking, तो no company like they will make a logo of same like Nike, वो इसको उल्टा बनाएंगे या उसको N को चेंज करेंगे Adidas. So in this the company will not be going to create the logo with the same dimension, they need to change the dimension. If they are unable to change, they will be put under the strict legal actions. So these are some sort of function and right granted for how much times. So अभी मैं इसको explain नहीं करूंगा, मेरे को पता है अभी 2 घंटे हो गए मेरे को बोलते, तो अभी इससे ज्यादा आप भी नहीं सुन पाओगे। So like the term of protection, अगर पेटेंट की बात करें तो पेटेंट रेस्ट अप टू 20 years, 20 साल तक पेटेंट रहेगा, बट कॉपी राइट जो है एंड ट्रेडमार्क है, इट कैन लॉन्ग लास्ट अप टू 70+ years। तो पेटेंट आपने कुछ डिजाइन पेटेंट किया तो 20 साल के बाद कोई और कंपनी उसको लीगली वही चीज बना के बेच सकती है, बिकॉज आपने बनाया उसको बना के बेच के बंद कर दिया, तो अनदर कंपनी हैज स्टार्टेड द वर्क। लाइक इन द कंपनीज द सेम मॉडल्स आर Nokia 6600, same models are available in the Samsung, same model are available Vivo, like Nokia 6600 mobile. So that time it was their patent, but nowadays anyone can use it. So this I'll share it with you. So these are some challenges, because CAD files are digital and they can be easily shared for so that anyone can duplicate. And other one is unauthorized replication of the patent design or copyright model. So मेरा जो कंपनी है, सो इन just give me 1 minute please, just give me 1 minute. So unauthorized replication of the patent design are there. So as I told you, duplicacy, Indian market is totally related or totally depend upon the डुप्लीकेसी। दे वो बोलते हैं कि कोई बात नहीं, केस होगा तो कर लेंगे, भुगत लेंगे केस, कोई बात नहीं, आप डुप्लीकेट करके चीजों को बेचना शुरू करो। इन द मेन टाइम दे विल अर्न मच प्रॉफिट फॉर द एनी न्यू इन्वेंशन को वो कॉपी करके, तो इन द मीन टाइम कंपनी को इतना प्रॉफिट भी नहीं हुआ होता, कोई लोकल कंपनी दे जस्ट कॉपी द मॉडल एंड उसको बेच के उतना प्रॉफिट भी कमा लेते हैं, केस चलता है 10-15 साल के लिए, उसके बाद सम सॉर्ट ऑफ पैसा देके वो निकल जाते हैं। तो दैट इज infringement of this unauthorized replication of the files. So your feedback is really important to me. Just give your valuable feedback to me. I'll just share this scan code to the sir also. So Gurpej sir, thank you very much, and thanks for giving me a chance to explore my knowledge in front of you all teachers. Thank you very much to listen me from the past 2 hours. Thank you very much.
Wonderful session, sir. Thank you so much.
Thank you, ma'am. Thank you. Thank you, ma'am. Any questions? So you are free to ask any question.
Thank you, sir. It's really a wonderful session, sir.
Thank you very much, sir. Thank you.
Sir, actually, I have one question, one doubt in my mind.
Yes,
Sir,
sir.
in these designs, we are using FEM techniques for simulations.
No, sir. For simulation, we have number of different there are the two kind of simulation, sir. One simulation is the actual simulation, other simulation is the virtual simulation. For virtual simulation, there are number of good platforms are available, like maybe you have ever heard about the ANSYS,
Yes.
or that in the CAD, in almost nowadays, in almost every CAD software, there are the two modules are companies are offering free of cost. One is computer aided engineering, and other one is the geometric modeling. So in that geometric modeling, so how to reduce the weight of the component, so they are targeting about that only. And in the computer aided engineering, FAE, it's a finite element analysis, so they are offering free of cost. So if we are good in CAD, so we can be easily optimize that analyze part in the CAD only.
Okay.
Yes.
Thank you, sir. Thank you.
Thank you, sir. Any more questions, sir? Okay,
Thank
sir.
you, Neeraj Mahiji.
Thank you,
Thanks for
sir.
this wonderful presentation. I
Thank
really
you.
appreciate that. The
Thank
way
you,
you
sir.
have elaborated and taken the live examples, I believe
Hmm.
that all the participants have understood very well. And
Thank you, sir. Thank you very
this
much.
is not the end, sir. This is the beginning, and we want that we should will remain in touch with you and
Right,
many
sir.
more events where we will include you too also, sir.
Thank you, sir. Thank you very much, sir.
So,
Thank you, sir.
on behalf of Amritsar Group of Colleges, I extend my thanks to you for
Thank you, sir.
sparing the valuable time out of your busy schedule.
Thank you, sir.
Thank you, Neeraj Mahiji.
Thank you, sir. Thank you very much, sir. Thank you.